This is a brief guide to spotting and solving S-parameter alias effects in the SI9000E. You can see two graphs on the title slide here, one with an effect at the low frequency around about 500 MHz and the other one showing fairly smooth S-parameter output. So on this first slide, what causes this? You can see a glitch at around 500 MHz. Is that a real effect, or is it some artifact of the modelling that we've used? This is exactly the same structure, remodelled, but now the S parameters look credible. If we take a look at the settings in the SI9000, you can see there are 200 frequency steps for the S parameters, and you can see that only 20 frequency steps to calculate the underlying RLGC parameters. We do this because field solvers are quite compute intensive, and on complex structures it can take quite a long time to field solve each structure at each frequency. So it's a useful shortcut to take a limited number of frequency steps to get the RLGC and then calculate rapidly many more S parameter steps. However, there's a catch, and you can see it here that something's gone wrong at the low frequency. The S parameter curves don't look as they should. So focusing again on the frequency steps, there's 20. If I run that now up to 180, you can see the S parameters are smoothed out, and I'll show it to you a second time. So go back 20 steps, and there's that glitch at the low frequency. That's caused because the skin effect is starting to develop, and the RLGC is changing fast between each step, so you're getting an alias effect on the graph. Go back to 180 steps in the frequency, and you can see that the S parameters are now plotting smoothly. So in summary, if there's anything that looks odd with your S parameters, especially at the low frequency, it's worth increasing the number of frequency steps. It might take a bit longer to calculate, but it will smooth out any lumps and bumps that you weren't expecting at the low frequency. Just to recap, field solve calculations are compute intensive, S parameter calculations far less so. And if the underlying RLGC values used to calculate the S parameters are changing rapidly, such as during reduction of skin depth at the lower frequencies, you're going to risk seeing alias effects. You solve this by increasing the F steps until the alias is eliminated. Thanks very much for watching this brief video on how to solve aliasing in SI9000 and S parameter calculations in general. And if you'd like further information or a product demonstration, please do contact the people listed on this slide.